Alright, hello YouTube. Appreciate your interest in this video. The disclaimer is I am by no means an expert. This is the first M800 that I've ever seen here. Don't know an awful lot about it, but I can tell you this much. Trying to find information on it is kind of like trying to find Casper the Unfriendly Ghost. If you have an M800, I'm going to do for you what makes things real easy. When you're looking stuff up on YouTube, this is something I ran into. And I don't mean any disrespect to, YouTube or anything like that. But sometimes it's very, very hard to see what's in front of people. And point is, I'm not going to make that mistake. Because what I've been looking for is a comparison to see what's in some other M800s, and haven't been able to see that. So anyway, took this on as a project several months ago. So every month that goes by, I get a little bit closer and a little bit closer, and eventually we'll start powering it up. I did check the board here that I built for it. Don't see any issues with that, but once again, that was just a dry run test without a lot of RF happening in the unit. So, but anyway, I wanted to address something here that I saw from the very, very get-go with this amp. That is the PC board on it is what I would consider to be a little bit substandard, maybe more than just a little bit. The grounding on this board seems to be very, very poor in my method of thinking. I put a lot of weight on construction practices. I really do. I think they can make or break the project. So what I did was I stripped out some RG174 silver plated, and I cleaned these grounds off real good and soldered some RG174 braid down to them and pulled it right across the emitter junctions. I put some real good solid copper ring terminals up here. Actually, I just have brass screws in there. Brass going into aluminum is probably a bad idea, but that's all I could find right now. Now I put some HG 454s into this guy, and we're going to see what happens with that eventually. Now I strapped these down. I guess somebody would probably call that strapping them. There's people out there that are far more experienced than I am. They could probably tell you that the do's and the don'ts and the pros and the cons of that. But I did that for a reason here, because I thought it would be more beneficial than a nuisance or a problem. Because I wanted to try to eliminate any resistive or inductive reactive component that this board could possibly be suffering from. So that's why I strapped them down. Just looking at the resistive component alone, having 100 millivolts drop somewhere can be pretty substantial when you're looking at transistors in terms of saturation and stuff. So anyway, I took some foil tape, which ideally wasn't what I wanted, and that seems to be a common story. Cleaned all the adhesive off of it. It was actually kind of like acrylic based or something, and that was a whole can of worms doing that. But then tinned the inside of it, folded it, tinned it, folded it, and kept doing that until I got about 5 or 6 layers of foil, so it would solder through the whole way down through. So that's what I used for this strap. So I just bust all these grounds straight across. The other thing too I did was once again, I took some really good quality solid copper ring terminals, and see if I got one here, and I sheared the top off of it and got it to the point at which it was pretty pliable here at this joint, so that it would bend easily. Otherwise, when you torque this down, it would bind up and possibly break or crack something trying to conform. And that worked out pretty well. Drew these down, and of course, as you draw it clockwise, it spins and goes up against the transistor body, and then pulls the emitter lead tight down to the board. The only drawback I saw to doing that is it gives a direct connection into the heat sink. So if these ring terminals were setting in here, like say it was over here on this side, and the ring terminal was setting this way towards the center instead of drawing up towards the side, and if you had one over here the same way that was setting more towards the inside, it absolutely pulled all the heat, and you couldn't get enough heat to get this to flow down through. So that was something that I learned. I ended up hitting this with probably like 120, 150 watts in some places to get that to flow the whole way down to the board surface. There's no pi network on the output of this driver, and I'm not sure why. Be that as it may, and take it as you want. I would like to put a trimmer here, but you know, at 25 bucks a trimmer, the idea isn't overwhelming, and you got to kind of read between the lines of what I want to say about that. I did happen to maybe catch a glimpse of one of these on somebody's table at one point in time, and it looked to me like it might have had 5 trimmers over here in this section, but once again it was a blur. Really couldn't tell. So if it had one on here, 1, 2, 3, 4, 5, yeah, if it had a pi network here and had a trimmer on the input transformer, that would have made sense as to why I thought I saw 5 trimmers on their unit. So I don't know, I'm just throwing that in there for informational purposes, because this unit's a hard thing to find. And of course, relating back to the board, the PC board quality, I don't know that you'd even consider this a 2-ounce plated board. I just really don't know. It almost acts like it's got a coating on it, but trust me, this thing's had enough flux and isopropyl and CRC on it that if there was any kind of coating on it, it would no longer be there. But trying to solder to it's pretty incredible. When you get enough heat for it to flow, you hear tink, 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 knowing full well that the copper separated from the board. And I knew that was going to be an issue because the pads burn off over here when the preamp board supposedly caught on fire. So, you know, I could tell from the way the traces separated that the board quality stunk really bad. So you can see I bust them across, tacked them down every 1.5 inches where there was actually still path at, and then just epoxied the wires down. Up here in the corner is kind of an interesting thing. You're probably looking at that saying, what in the world is that? Well, that's the redundancy that I do, because when I put a lot of time into something, I don't want to think that one of these days when I'm gone, some idiot's going to get a hold of it and not have the appropriate fuse in it and put reverse polarity on it and destroy the whole box. So I put a lot of weight on the simple things. I didn't ideally have the diodes that I wanted to put in here, and I wasn't going to go through the expense and the trouble of finding them. But what I did have was some MUR 460s. They have a forward surge of about 150 amps for probably a half of a sine wave. I used them and come up with a forward surge current that I'm pretty happy with by using 6 of them. You can see I wrapped these with solder wick because of the right value fuse isn't in there when the diode's short. Eventually they're only going to short for so long, and then they're going to burn open, and then the process of that, solder's going to melt and things are going to come undone. And if the unit is still connected in reverse polarity at that point in time, and connections melt off, then the unit's still vulnerable to reverse polarity. So I'm hoping you can kind of see my logic there. You want to create a high current path that doesn't fall apart, because you just never know what somebody's going to do. I just flowed over top as crudely as I could. I didn't want to hit too much heat on this board and separate that copper from it, so I just pulled a ground path over here to take whatever current that may end up being. So enough about that redundancy. One other thing too that I've noticed that I think probably should be changed is relying upon a trimmer for its sole value is generally not a good idea, because compression trimmers move, vibration, bouncing around, stuff like that. So what I'm saying is, ideally, this trimmer cap should probably be a fraction of the value that it actually is, and there should be a pad cap that has a more substantial value underneath this guy here. So if this capacitance varies, it's going to vary by a small amount, and it's going to be carried by the larger capacitance below it. And I'm hoping that makes sense to you, because then there's no room for any huge fluctuations. Actually, I'm going to go ahead and address that issue. Now back to the grounding here. I'm not sure what to do about this, if anything. There's not much passing through underneath these transformers, and everything seems to be the common tie point RF wise at these points, because that's where the transformer is grounded. But there's only about well, maybe 3/8, probably less than 3/8 of an inch, probably more than 5/16 carrying across underneath those transformers. And I really don't want to do this, but I'm almost thinking about pulling these transformers out of here and seeing if there's something that I can do about that to bump that up a bit, because it comes over here and then it hits this, which is dead-ended. That's dead-ended. The only thing carrying the ground is the shield of the coax cable. Well, actually, there's a loop. There's actually a ground loop formed here, because that ground follows through to this point underneath the transformers, and then the shield follows through from the same point over here over to the same point over here. So that's kind of how that is. Now back here, the shield is the only thing, with the exception of one little tiny area that's actually up here in the front, that ties mainly the grounds on the input side back to the ground over here. And the only way to really substantially bridge that gap is through the shield and the coax. It seems to have more integrity than what the path is over here on this side that you really can't see. I'd actually have to take this board out for you to see how narrow stuff is in this. So I'm not sure what to do about that one either. Now, believe it or not, I spent probably about 3 hours just to cut this piece of braid, tin it in the right spots. It's mil-spec braid, and it must be high temperature. I'm guessing that it may be nickel plated, but you know, I just don't know for sure, because generally my experience has been that metals that are made for very high temp ring terminals in particular have the same soldering characteristic that this stuff does. It takes tons and tons of heat. But then when you get that much heat on it, suddenly the solder flows very beautifully. So I don't know if it's nickel or what it might be. But it took a couple hours just to get that piece of braid in there and formed, get some holes drilled in it, and put some cap head screws down in it, cleaned this whole edge of the board off with Scotch-Brite on the good old-fashioned dog nail grinder, the most versatile tool I have. And tinned it up and tacked it down. I tinned the back side of this before, and tinned the path as well before, so when I hit it with solder from the top, it would all flow through. The only thing that was carrying, let's see if I can find what I did with them. I might actually pitch them in this container here. There was two of these guys here that were riveted to the SO239, which were soldered down to ground. So I just drilled them out and took them off of there. So I'm gonna bolt these SO239s through that piece of ground braid and go with it that route. But it seems a little redundant for all the work that I went through putting that braid in, not to try to create some more of a RF current path on the output back to it. So I'm kind of stumped on that, because as soon as you, like I said, as soon as you get enough heat on this board, it separates. I took all those nuts out that I could really easily get out underneath the board and clean them off, the standoff nuts and stuff. This, I don't know what's up with the plating on this wire here. It does not carry solder well at all. So I'm going to have to grind this guy out and see if I can get solder to flow better on him. Also, too, I had to grind these out here because my braid came up higher than I thought it was over here. Once again, it was a trusty nail grinder for the K9. And I'll tell you what, laugh if you want, but these things are wonderful. This is the most indispensable tool that I've ever had. I've had this thing smoking, screaming hot, and it continues to work. The only downfall of these things is the springs in them are absolute junk. Every couple times you got to be putting bigger solder blobs here, putting the hemostats in, and pulling the springs out. So eventually one day I'm going to take this thing apart and I'm going to put some big beefy brass springs in there, because that's the flaw of this unit. If it wasn't for that, it would be pretty wonderful, and it still is. So just thought I'd throw that in there. Now, what in the world did I do with the fuse holder for this? So I think what I'm going to do is move this fuse holder over, because this just doesn't seem like the most ideal situation to me. You got an inductor there. You know, I took care of the trimmer problem by notching this out, so that when these screws eventually loosened up someday down the road, some idiot wouldn't inadvertently rip that trimmer right off the board with the play. But it just doesn't make sense to have something metallic sitting so close to an inductor. So I think what I'm going to do is move this over there. The only problem is now I got to unwrap all this silver plated wire here. But I think that would be best, just to move the fuse holder over here. You know, ideally what I would have liked to have done with this is And I'm kind of crazy about stuff, I really am. This is the way this amp should have been made. Just like that. That's the way it should have been built. I don't want to make you laugh at me or anything, but I don't know why in the heck people do dumb things like this. Why in the hell do you put a heatsink facing down? Why do you do that? You know, it's just like putting gutters on your house and running the gutters, you know, a half an inch up grade over the course of a foot of distance. Just don't make good sense. But you know, that's an awful lot of work to flip this guy upside down. And you know, I did it on the Texas Star, and it wasn't that bad on there. But to flip this one upside down, you know, I'd have to make a new faceplate for it, and that's a lot of work. Cutting square holes with primitive tools is not not a good task. Not a good task at all. But ideally, I would have liked to have had this mounted upside down. So, hey, enough about that. But that's where I'm at on this project. Hope maybe I said something that helps somebody with this. There was one thing here that I wanted to point out that I caught that I didn't like, and wasn't through no fault of the builder of this unit. It was through an oversight on my part on how I do things. And here's my piece of, I don't know what it is, 18 or 20, probably 20 Teflon coming down. I was just going to solder this right down to that piece of RG400 or whatever that's there. And then I looked at it and I said, oh man, that kind of looks to me like you're asking for trouble there. Because I had to feed this VCC path straight across pretty much the bottom of the board. And I certainly don't like the idea. This is bias power to the relay. I certainly don't like the idea of that wire running parallel to that path. Maybe I'm being too critical, but I don't like that. I kind of view that as an accident waiting to happen. So I think what I'm going to have to do is just try to find some RG400 somewhere and take this piece off, and maybe I can, once I get this off, I can see a little bit better with what that ground's doing, and improve something there. I'm not sure. I'm just going to have to run it up, maybe just directly connect it up to the relay contact. I don't know which one it's going to. Oh, the top one. Yeah, it's going to the top one. So that's where I'm at. That's where I'm at with that one. Hey, appreciate you watching very much. Hope maybe seeing this unit up close and personal helped you with some kind of issue or question, maybe, if you have one of these. So I appreciate you watching very much. Have yourself a wonderful day.